Okay, these are the steps to do limit x to infinite algebraically. First, you need to find the largest exponent. So first you find the largest exponent, then you divide each term by that exponent that you chose on the first step. Then you simplify them. When you simplify them, you change the x to infinite. The fifth step, you simplify again. Then you solve one divided by infinite, and finally you solve the equation to get your final product.
Okay, this is our problem, algebraically limit x to infinite. So our number one rule is find the largest exponent. So in this problem, our largest exponents are these ones. And then number two is divide each term by that exponent. So we're gonna divide 10x to the second power divided by that exponent. Then the same with the rest of the numbers. Then divided by 3 minus 2. And then we're gonna cancel out. This cancels because it's the same. Then 1x, we cancel it, so we cancel 1x down there. This stays like that. This one stays like that because there's no common variables. And this one cancels. So we're gonna be left out with 10 minus 3x plus 1x to the second power divided by 3x to the second power minus 2. And then in this step number 4, it says that the x, the variable, it's gonna turn into an infinite. So these variables, which are the x's, we're gonna turn them into infinites. So infinite. This one turns into infinite, and this one too. Infinite. And then our step number 5 and 6 and 7 is to solve. So we're gonna cancel out every fraction that has an infinite. We're gonna cancel them. So cancels, cancels, and cancels. So our final answer would be to divide 10 over negative 2, and that's equal to negative 5. And our final answer is limit when x tends to infinite, it's negative 5.
Hello, I'm gonna do a problem of differentiation, which is the derivatives with using the chain rule. So this is our problem, and we will have to find using this formula, which u makes is this part. We first have to absolve this square root and bring all the problem on the top. So I'll have to do it this way. So it'll be 4 parenthesis x cubed minus 6x minus, because we brought it up, and it's gonna be 1 divided by 2. That's the exponent. So this is our problem. This is what we're gonna be using. So using this formula, we'll have to find what u n minus 1 and the u prime of u. So firstly, u will be x cubed minus 6x. U prime will be, when you derive, when you differentiate this problem, it will become 3x squared minus 6. N will be the exponent, which is minus 1/2. And n minus 1 will be minus 1/2 minus 1 will be minus 3 out of 2. So when you bring that all together, it'll be minus 4 times minus 1/2, which will be minus 2, parenthesis u, which is x cubed minus 6x, to the exponent of n minus 1, which is minus 3 out of 2, times prime of u, which is, we already got it, 3x squared minus 6. So right here, we're gonna multiply minus 2 times this, because this does not have an exponent, which will bring us to minus 6x squared minus 12, parenthesis, and times u, which is x cubed minus 6x to the minus 3 out of 2. And we cannot leave it like this, because this is minus. So we'll just convert it to minus 6x squared minus 12 divided by the square root of x cubed minus 6x cubed. And this will be our final answer, and this will be equal to prime of f, x.